Okay, you have to have a problem that has pine cones falling out of the tree, you know. You just do, you know. So here's this pine cone. I don't know how you draw a pine cone there. Looks like a, kind of looks like a turd, but anyway. And the thing falls out of the tree, right? 45 meters. Notice this one doesn't have a picture drawn, right? I highly recommend you draw a picture, okay? And just before it strikes the ground, pine cone, okay, just before it strikes the ground, it is going 22.0 meters per second, right? And then it says, what is the average force of air friction that acts on the pine cone as it falls? Well, presumably it would be going faster than 22 meters per second if there hadn't been air friction, right? So one thing you could do is figure out that the velocity that it would have should be like square root of 2gh or something like that, right? And so if I did that 2 times 9.8 times 45, and then square root of that, should be going actually about 30 meters per second, but it's not, right? So, you know. Okay, so what we do with this thing is we're basically going to say, okay, here before it was dropped, I think all it had was mgh, right? Okay. It wasn't moving, and we didn't throw it down, so it definitely, all it had was mgh, right? And then where did that go to? Well, I think since it's talking about a force, and that force would be a force that slows it down, I think there's a right side force times distance, a slows you down work, okay? And then obviously it's moving. But since it's all the way at the bottom here, right? Get rid of that, we don't want to do that, right? Okay, since it's all the way at the bottom here, the height is 0, so there's no mgh, okay? So that's all there is, and now we just plug in numbers, right? 0.124 times 9.8 times 45, it's a 5, equals force times distance. So force, and then the distance over which the force acts is 45 meters. Now, notice how it says average force. Probably the force is more at the bottom, less at the top, right? Most drag forces increase with velocity, right? Okay, so plus 1/2 0.124 times 22 squared, right? Okay, so let's bust these out. 0.124 times 9.8 times 45. This is 54.684. 45 f plus, and then let's see, 0.5 times 0.124 times 22 squared. This is 30.008. Okay, so the next step is I'm going to subtract this from both sides, right? Okay, so 54.684 minus 30.008. I get 24.676 equals 45 f, right? And now I can divide by 45, both sides by 45. So divide by 45, and I get 0.54835 equals f, right? And so then it looks like we have 3 digits, 3 there, and 3 there, and 3 there, right? So we can write this, we can round this thing to this place. And that does not look like quite the right rounding. I guess I would have to say 0.548. Newtons. Ta-da. And I think the difference is that, like in IB physics, we use like a 1 there, and so I probably used a 1 accidentally. Come to class ready to try these problems. They're like the best problems.